Okay, this is a continuation of the 48 notes. My recording got interrupted somehow, and I didn't want to redo the first page, so let's do it as a second page. So we're trying to find the area. So find the area of a single petal in this flower. So I guess we could sketch it first. It's a rose curve, and it has 3 petals. It has a radius of 2. I mean, there's the easy way is to not sketch it and say, well, a single petal would be 1/3 of all of the area and all the petals. And to find the area in all the petals, you'd go 0 to pi, not 2 pi, because it has an odd number of petals. And so this would be the setup. This would do it. And so I think that would be the easier way to do it and not sketch it. If you sketched it, you kind of zero on one of the single petals, but that would be a lot of extra work. I'll go ahead and do it. So plus or minus 2 equals 2 sine 3 theta, plus or minus 1 equals sine 3 theta. So 3 theta equals pi over 2 plus pi k. So theta equals pi over 6 plus pi over 3k. So theta equals pi over 6, pi over 2, and 5 pi over 6. The graph. Do a quick sketch of the graph. Has a radius of 2. So we'd sketch circle lightly dashed, and then pi over 6. So you want to graph pi over 3, 2 pi over 3, pi over 6. We cut that in half. That's where the first petal will be, and pi over 2 is going to be down here. That's the second petal, and then the third petal is going to be over here at 5 pi over 6. So the graph would look like that. So I mean, I can graph very quick, but I still think that's a lot of work. So if you want to do one petal, we could say, well, then that would just be 1/2, and we say 0 to pi over 3, because the petal starts here at 0 and ends at pi over 3. And then you can do the 2 sine 3 theta square d theta inside. So you could do that. I think it would be quicker to say, well, let's just do the whole flower and divide it by 3 because they're equal sized petals. So different ways to do it. You could do symmetry. You could say, you know what, let's find half of a petal. Half a petal would be 0 to pi over 6. That'd be one of them. I mean, there's other ones you could pick to do. I think this would be the simplest one because it involves 0 as one of the limits. But I mean, so you got different ways. Okay, now for another slightly more challenging one, find the area between these two circles. So they're both circles. Good setup. And so 0, pi over 2 pi is all you need for both of these. And so when you plug 0 into here, you get 1, 0, 1. For this one, it's going to be 2, 0, 2. So they're both horizontal. So we graph them together, kind of see how they interact with each other. It's the area between the circles. So okay, so the bigger one's 0, 2, and then it's back to here, and in between, we would have a radius of 1 the whole time. So that's the bigger one. The smaller one is 0, 1, goes to here, radius of 1/2. And so it looks like this. So the area in between them, I would say they're talking about this. Now both graphs start here and they move that way. It's kind of good to know where they start. And so what we could do is just use symmetry and just do half of it. And so the area of this one, the way you find that area, is you say we go 0 to pi over 2 is when it hits here. 0 to pi over 2. And that's the bigger one, which is the 2 cosine one, square d theta, and then subtract the smaller one, 0 to pi over 2. And that one's going to be just cosine theta squared d theta. So that would be the setup. And I'm going to go ahead and finish this one just to have just a little extra practice here. That part of it, but that's how you do it. I guess you could also have found just, well, this is a circle with the radius of 1, pi r squared. This is a circle with the radius of 1/2, pi r squared. Subtract that one from that one. It should give you the same thing, but that's not what I'd be looking for on homework and stuff. On a test, I guess if there's something that can be done easily with geometry, go ahead and take advantage of it. But for right now, we're trying to practice this. So let's see. The 2 gets squared. The 2's cancel. The 2 gets squared, so we get 4 0 to pi over 2 of cosine squared. And here, you get 0 to pi over 2 of cosine squared. We could combine these guys together. They have the same limits. They have the same thing inside, so it'd be 4 minus 1. So we could do 3 of these. So we're going to have to use that double angle identity for cosine. So this is going to be a 1/2 plus 1/2 cosine double angle. So then we would get 1/2 theta plus 1/4 sine 2 theta, and then 0 to pi over 2. So we would get pi over 4 plus 1/4. Sine of pi is 0. And then you plug 0 in, you get 0, and sine of 0 is 0. So this one works out pretty nice. The answer is 3 pi over 4. That is the area between those. Okay, for your assignment, it's out of the book. Try those problems. Check your odds in the back of your book. And that's it. Draw some good pictures. Get your setups right. That's probably the hardest part of these, I think.